Black holes are gatherers, not hunters. They lie in wait until a hapless star wanders by. When the star gets close enough, the black hole's gravitational grasp violently rips it apart and sloppily devours its gases while belching out intense radiation. Astronomers using NASA's Hubble Space Telescope have recorded a star's final moments in detail as it gets gobbled up by a black hole. Hello and welcome to KYC News. Please don't forget to subscribe and hit the bell icon. These are termed tidal disruption events, but the wording belies the complex, raw violence of a black hole encounter. There is a balance between the black hole's gravity pulling in star stuff and radiation blowing material out. In other words, black holes are messy eaters. Astronomers are using Hubble to find out the details of what happens when a wayward star plunges into the gravitational abyss. Hubble can't photograph the 2022 DSB tidal events mayhem up close, since the munched-up star is nearly 300 million light-years away at the core of the galaxy ESO 583G004. But astronomers used Hubble's powerful ultraviolet sensitivity to study the light from the shredded star, which include hydrogen, carbon, and more. The spectroscopy provides forensic clues to the black hole homicide. About 100 tidal disruption events around black holes have been detected by astronomers using various telescopes. NASA recently reported that several of its high-energy space observatories spotted another black hole tidal disruption event on March 1, 2021, and it happened in another galaxy. Unlike Hubble observations, data was collected in X-ray light from an extremely hot corona around the black hole that formed after the star was already torn apart. However, there are still very few tidal events that are observed in ultraviolet light given the observing time. This is really unfortunate because there's a lot of information that you can get from the ultraviolet spectra, said Emily Engelfeller of the Center for Astrophysics, Harvard and Smithsonian, CFA, in Cambridge, Massachusetts. We're excited because we can get these details about what the debris is doing. The tidal event can tell us a lot about a black hole. Changes in the doomed star's condition are taking place on the order of days or months. Astronomers using NASA's Hubble Space Telescope have recorded a star's final moments in detail as it gets gobbled up by a black hole. Credits: NASA's Goddard Space Flight Center, lead producer, Paul Morris. For any given galaxy with a quiescent supermassive black hole at the center, it's estimated that the stellar shredding happens only a few times in every 100,000 years. This 2022 DSB stellar snacking event was first caught on March 1, 2022 by the All-Sky Automated Survey for Supernovae, ASSN or ASSASSIN, a network of ground-based telescopes that surveys the extragalactic sky roughly once a week for violent, variable, and transient events that are shaping our universe. This energetic collision was close enough to Earth and bright enough for the Hubble astronomers to do ultraviolet spectroscopy over a longer than normal period of time. Typically, these events are hard to observe. You get maybe a few observations at the beginning of the disruption when it's really bright. Our program is different in that it is designed to look at a few tidal events over a year to see what happens, said Peter Maxim of the CFA. We saw this early enough that we could observe it at these very intense black hole accretion stages. We saw the accretion rate drop as it turned to a trickle over time. The Hubble spectroscopic data are interpreted as coming from a very bright, hot, donut-shaped area of gas that was once the star. This area, known as a torus, is the size of the solar system and is swirling around a black hole in the middle. We're looking somewhere on the edge of that donut. We're seeing a stellar wind from the black hole sweeping over the surface that's being projected towards us at speeds of 20 million miles per hour, 3% the speed of light, said Maxim. We really are still getting our heads around the event. You shred the star and then it's got this material that's making its way into the black hole. And so you've got models where you think you know what is going on, and then you've got what you actually see. This is an exciting place for scientists to be, right at the interface of the known and the unknown. The results were reported at the 241st meeting of the American Astronomical Society in Seattle, Washington. The Hubble Space Telescope is a project of international cooperation between NASA and ESA. NASA's Goddard Space Flight Center in Greenbelt, Maryland, manages the telescope. The Space Telescope Science Institute, STSCI, in Baltimore, Maryland, conducts Hubble and Webb science operations. STSCI is operated for NASA by the Association of Universities for Research in Astronomy in Washington, D.C. Astronomers using NASA's Hubble Space Telescope have captured the last moments of a star. This telescope has recorded what happens to a star just before it is swallowed by a black hole. Before the black hole swallowed the star, it stretched into a donut shape. This view was captured by the Hubble Space Telescope. The supermassive black hole is located at a distance of 300 million light-years from Earth in the core of the galaxy ESO 583G004. When the star came very close to this black hole, then this black hole disintegrated the star, due to which a powerful beam of ultraviolet light came out. Related news. When a black hole feeds, or swallows, a star, its immense gravity exerts enormous tidal forces on the star. As the star comes closer to the mouth of the black hole, the gravity of the black hole affects the near area of the star more than the faraway area. This asymmetry turns the star into a long, noodle-like string that wraps tightly around the black hole layer, like a noodle wrapped around a fork. The star breaks down and spins like a noodle around the black hole. Photo, NASA. Its shape then starts to resemble a donut. This donut of hot plasma accelerates around the black hole and releases immense energy, producing a distinctive bright flash that is caught by optical, X-ray, and radio wave telescopes. The unique brightness of this black hole's feeding session inspired astronomers to study tidal disruption events. Researchers say that this can give new information about the last moments of the star. It is very unusual for a star to disintegrate in such a shape. The outer atmospheric layers of the star disintegrate first. Then, they revolve around the black hole and form a ball-like shape. The remaining part of the star also starts rotating around the black hole. It is said that the black hole swallows everything. Despite this, most of the star is saved. A black hole swallows only 1% of a normal star. The stellar shredding is thought to occur just a few times every 100,000 years for any given galaxy with a quiescent supermassive black hole at its center. The All-Sky Automated Survey for Supernovae, ASSN or Assassin, a network of ground-based telescopes that scans the extragalactic sky roughly once a week for violent, variable, and transient events that are shaping our universe, first discovered this at 2022 DSB Stellar Snacking event on March 1, 2022. Because of how close and bright this intense collision was to Earth, Hubble astronomers could conduct ultraviolet spectroscopy for longer than usual. Peter Maxim of the CFA said, "Typically, these events are hard to observe. You get a few observations at the beginning of the disruption when it's bright. Our program is different because it is designed to look at a few tidal events over a year to see what happens. We saw this early enough to observe these intense black hole accretion stages. We saw the accretion rate drop as it turned to a trickle over time. According to the Hubble spectroscopic data, the former star is now believed to have left behind a highly brilliant, hot, donut-shaped gas region. This region, called a torus, has a black hole in the center and is the size of the solar system." Thanks for watching and see you on next video.
Yeah, yeah.